All right, section 7.3, we're learning how to apply that matrix algebra that we started last section. So here we'll deal with matrix equations and using the inverse of a square matrix to solve an equation of a system of equations using matrices. So to start out that section, we're going to do setting up our matrix equations. So our first skill is in 7.3.1 is just to write a system of linear equations as a matrix equation. So the thing to understand here is that a system of linear equations can be represented with a matrix equation. Okay, so here's a couple of examples. So if I have this matrix equation 2, 1, negative 3, I'm going to write that over here too. 2, 1, negative 3, 5. If I were to multiply those two matrices together, so this one's a 2 by 2, this one's a 2 by 1, those center numbers match, so that means the product exists, and the product will be a 2 by 1 matrix. So when I multiply those two together, what do I get? Let's see. I get the product will be, I'm going to get my fingers out. So I start with my finger on the top left corner, and I'm going to go along the rows in my top corner, and then going down. So the first row times the first column. So I'm having my 2 by 1. My 2 by 1 matrix. Actually, I'm going to make it big so I can show my work a little bit. And then with my finger, I slide along the top row on the left and the first column on the right. And I say 2 times x plus negative 3y. That's my first entry. And then I do that same process for the second row, first column. And that is 1 times x plus 5 times y. And so that's a 2 by 1 entry. This is one entry, one element, and this is the other element. So according to the original equation that I had, actually, so I can see that this is an equation. This on the left here multiplies to this system. And if I have it equal to the matrix negative 7, 9, so these are both 2 by 1 matrices, and if they're equal, then their elements must be equal. So that tells me that the 2x minus 3y equals negative 7, and the x plus 5y equals 9. So that's converting a matrix equation to a system of equations. And we can go vice versa. So say we're given this system of equations, then we can take our coefficients and put them into a coefficient matrix. Our variables go into a variable matrix, and the constants go into a constant matrix. And then I end up getting an equation, a matrix equation. A matrix A times the variables x equal B. All right, so let's look at our homework exercises where we have to write a system of linear equations as a matrix equation. We're not going to solve, I just want to practice writing them. So from this section, you're doing 1 through 7 odd. We're going to do 8 as an example. So this becomes, I have, let's see, I have 4 variables here. So I know that I'm going to have a matrix that's 4 elements wide. That's my coefficients. And I have 4 variables. So I have 4 rows. And I have equals, and then I have 4 constants. So that's a 4 variables times, 4 constant, 4, let's see. it's rows by columns. The number of rows is the number of equations. So that's 4 equations times 4 variables. And then the number of variables, we only have 1 column of variables and we only have 1 column of constants. Okay, so our coefficients. So think this column is going to be x, this column will be y, this column will be z's, and this column will be w's. So x, y, z, w. When we multiply them out, they get added in that order. Whatever's here times the x, whatever's here times the y, whatever's here goes times the z, and whatever's here gets times w to get that first equation. Okay, now let's plug in. Oops, too much. Sorry. Let's plug in those numbers now. Okay, so my coefficients are a 1 in front of the x, a 1 in front of the y, and -2 in front of the z, and a 1 in front of the w. And then on the next equation, we have 2, -1, 3. There's no w. W is missing, so that means it has a 0 coefficient. And the third equation, we have -1, 2, -3, +4. And then on the last equation, there's no x term, so that means that's a 0 coefficient. And then we have 1, 4, 6. So when I multiply these two matrices together, I will get these 4 equations in a 4x1 matrix. And on the right of that, we have 11, 17, 12, and 19. So when I multiply that first equation times the variables, I get 11. The second row coefficients times those variables, I would get 17, and then 12 and 19. So there is my matrix equation. So setting up my system of equations into a matrix equation. And that's all we're doing with 1 through 8.